Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang impedance combinations. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay tuturo ko naman sa inyo yung impedance combinations. So, dun sa previous video ko, ay naturo ko na sa inyo yung concept ng impedance, right? So, ngayon is ituturo ko naman sa inyo kung paano ba i-combine yung impedances. So, di ba sa DC circuits, nag-consider tayo ng iba't ibang combinations or connections ng resistors. Like series circuits, parallel circuits, series to parallel circuits, as well as yung Y-to-delta connections, right? So, same lang din naman yun dito sa impedance combinations. Yun nga lang, dahil AC na tayo, mas complex lang yung ating pag-compute kasi hindi na simple resistance lang yung ginagamit natin. But this time, impedances kung saan ginagawa nga nating phasors or complex number. So, mas complicated lang yung computation. Pero lahat ng concepts ng natutunan natin dun sa different connections dun sa DC is applicable din dito sa AC. Okay? So, basically, Ohm's law still applies to AC, right? So, when we consider Ohm's law in AC circuits, we have the formula I is equal to V over C. Same lang. Yun nga lang itong I, tsaka V and Z are in phasor form. So, it involves complex numbers already. Okay? So, yung first impedance combinations natin is yung series impedances. So, just like in DC circuits, applicable din yung mga formula natin dito sa AC circuits for series impedances. So, given the series impedances, Z1, Z2 to Zn, and then there is a voltage source supplying them, there will be a total current flowing in this circuit. So, to find the total impedance, add lang natin yung individual impedances doon sa circuit. So, Zt is equal to Z1 plus Z2 plus ... plus Zn. So, itong impedance na to is a complex number, right? It can be either purely resistive or it can be either purely reactive or combination, pwedeng R plus minus Jx. Okay? Tapos itong V of t, equal siya doon sa sum nung voltage drop doon sa individual impedances. So, Vt is equal to V sub 1 plus V sub 2 plus ... plus V sub n. And then It, since series, equal to lahat doon sa bawat current na dadaloy doon sa bawat impedances. So, It is equal to I sub 1 equal to I sub 2 equal ... equal I sub n. Okay? And then, also, voltage divider rule applies in AC circuit. So, voltage divider rule states that V sub n is equal to Z sub n over Z sub 1 plus Z sub 2 plus ... plus Z sub n times Vt. Okay? So, alam naman natin lahat to sa DC circuits kasi dun sa mga videos ko before. Okay? And then, we also have the parallel impedances. So, let's say, meron tayong parallel impedances from Z1, Z2, up to Zn, and then supplied by a voltage source, Vt, meron din total current na dadaloy dito sa circuit. So, ang total impedances ng ating parallel circuits is the reciprocal of the sum of the reciprocal ng ating individual impedances. Just like sa parallel resistors, right? So, we have Zt is equal to 1 over Z1 plus 1 over Z2 plus ... plus 1 over Zn. Okay? And then, kapag meron tayong parallel impedances, yung voltage drop across each impedance is equal lang. Principle of parallel connections, right? So, Vt is equal to V1 equals to V2 equals to ... equals to V sub n. And then this time, kapag parallel impedances naman, ang current natin yung madidivide doon sa bawat branch ng impedances. So, therefore, we have It is equal to the sum of the individual current doon sa bawat impedance branch. So, It is equal to I sub 1 plus I sub 2 plus ... plus I sub n. Or another formula daw for the total impedance is, so, di ba alam natin na dun sa previous video ko about admittance, it is the reciprocal of impedance. So, therefore, Zt is also equal to 1 over total admittance, where yung Yt can be the sum of the individual admittances noong ating parallel circuit. So, Yt is equal to Y sub 1 plus Y sub 2 plus ... plus Y sub n. Now, applicable naman this time sa parallel impedances yung current divider rule, kung saan In daw is equal to 1 over z sub n over 1 over z sub 1 plus 1 over z sub 2 plus dot 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 plus 1 over z sub n it. Or in terms of admittance, I sub n is equal to y sub n over y sub 1 plus y sub 2 plus dot 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 plus y sub n times I sub t. Okay, so same lang din naman lahat to, yung concept doon sa video ko about parallel circuits for DC. Okay? Next, we also have the delta to Y and Y to delta transformations in AC circuit. So, same lang din naman yung formula dito doon sa DC circuit, wherein, given this figure, we can transform Y to delta using this formula. Diba, sa Y to delta, ang formula niya is pare-paro silang numerator na ia-add yung impedances doon sa Y taken 2 at a time over doon sa impedance na opposite doon sa delta impedance na kino-consider natin. So, for example, itong ZA. So, diba, ZA, yung opposite sa kanya is itong Z1. So, yun yung denominator niya. And then, yung numerator is, i-multiply natin yung 2 impedances at a time. So, Z1 times Z2 plus Z2 times Z3 and then plus Z3 times Z1. Okay? And then, doon sa other resistance for the delta, yung ZB tsaka ZZ, ganun lang din yung pattern. Okay? For delta to Y naman, ang pattern naman dito is yung denominator nila is pare-pareho, which is the sum of the individual impedances doon sa delta. So, ZA plus ZB plus Z2. And then, for a specific Y impedance na kino-consider natin, let's say si Z1. Ito yun, di ba? I-multiply nyo yung dalawang impedance na naka-include sa kanya, which is itong ZC tsaka ZB, right? So, kaya yung numerator niya is ZB over ZC. Same lang din yung pattern kapag kinonsider natin yung other Y impedances na Z2 tsaka Z3. Okay, so tandaan nyo lang tong formula na to. Anyway, nire-recall lang naman natin yung natutunan natin sa DC. Yun nga lang, ang computation natin is mas complex kasi phasor na yung ginagamit natin sa impedance. Okay? So, para ma-illustrate natin yung iba't ibang impedance combinations, ay mag-solve tayo ng example. So, find input impedance of the circuit below. Assume that the circuit operates at omega equals 50 rad per second. So, ito raw yung circuit natin. Tapos, hanapin daw natin yung input impedance across these terminals. So, lagi kapag nagko-consider tayo ng AC circuits, lahat ng ating mga passive elements ay tinatransform natin into their impedance form. So, dito muna tayo sa 2 millifarad capacitor. So, di ba yung capacitor, ang impedance niya is 1 over J omega C. So, substitute natin yung value. 1 over J omega is given na 50. And then yung C na given, equal siya sa 2 times 10 raised to the negative 3 farad. Kasi 2 millifarad. So, using calculator, ano to? Negative J 10 ohms. Okay? Then dito naman sa 10 millifarad, 1 over J, so same omega na 50, times 10 raised to the negative 3 power. Millifarad din siya. So, equal yun saan? Negative J2 ohm. Tapos, ano pa? Itong resistor na dalawa, as is lang yan, di ba? Yung natin binabago sa impedance. So, si inductor na lang. So, si inductor naman, anong formula natin? So, Z sub L. So, kanina, Z sub C for capacitor. Ngayon, ano yung Z sub L or impedance for the inductor? J omega L, right? So, therefore, we have J times omega, 50 ulit, times yung L niya na 0.2 Henry. So, ilan to? J 10 ohms. Okay? So, ngayon, i-transform na natin itong circuit in terms of their impedances. Okay? So, ito, 2 millifarad, ilan na siya? Negative J 10 ohms. Itong 0.2 Henry, ilan na siya? J 10 ohm. Tapos, itong 10 millifarad, ilan na siya? Negative J 2 ohms. Okay? So, mapapansin nyo, hindi tayo single series combination lang or parallel combination lang. Meron tayong, itong branch na to, isang impedance, Tapos itong branch na to isang impedance, parallel. So para makuha yung total impedance is pwede nating kunin yung total impedance nitong parallel branch na to, then i-add natin dito sa series na negative J10 ohm, right? So let's say itong Z1 siya si negative J10 ohm, tapos itong branch na to Z2. So pag in-add natin yan, ano yung impedance niyan? 3 minus J2, right? Ohms. Tapos itong branch na to, let's say Z3, anong total impedance niyan? 8 plus J10 ohm. Okay? So sabi ko nga, Zn is equal to yung combination ng parallel branch na to, so Z2 parallel to Z3 plus nakaseries dito sa Z1, yung negative J10 ohm. So therefore, ito yung gagamitin nating formula to find Zn. So substitute natin yung value. So Z1 is negative J10 ohm plus, so formula for parallel is, anyway, hindi ko napakita na pwede parang gamitin din dito yung shortcut for two parallel circuit. Yung product nung dalawang impedances over sum nung dalawang impedances. So, multiply natin tong Z2 tsaka Z3, 3 minus J2 times 8 plus J10, then divided by their sum. So, 3 minus J2 plus 8 plus J10. Okay? So, ito yung input natin sa calcu para mahanap natin yung Zin. So, dito naman sa AC circuit, it's just a matter of using calculators lang to evaluate the complex number, right? So, input na lang natin sa calcu, then masasolve natin yung final answer. So, kahit in complex form na lang, equal siya sa 3.22 minus J times 11.07 ohm. So, therefore, ito yung Zin. So, mapapansin nyo, negative J tayo. Ibig sabihin, capacitive impedance tayo. Okay? Kasi negative. Di ba kapag negative, ibig sabihin, lamang yung capacitive impedance doon sa inductive impedance. Okay? Next, we have determine V sub O of T in the circuit below. So, meron ulit tayong circuit. So, hanapin daw natin itong V sub O of T given this circuit. So, parang siya yung voltage dito sa inductor. So, again, transfer muna natin into phasor domain yung lahat ng circuit elements. So, itong voltage source, in polar form, equal siya saan? So, 20 yung magnitude, then angle, yung given phase angle niya na negative 15 degree. So, itong resistor as is, in terms of its impedance, so 60 ohm, dito sa 10 millifarad capacitor, so, impedance for capacitor is 1 over J omega C. Substitute natin, 1 over J omega, base dito sa ating voltage source, yung nakamultiply sa T, which is 4. So, siya si omega. So, times 4, then times the capacitance na 10 millifarad. So, times 10 raised to negative 3. So, using calculator, ilan to? Negative J, 25 ohms. Then, last, itong inductor, impedance for inductor is equal to J omega L. Substitute natin, we have J times omega, 4. Then, yung inductance nyo na 5 Henry. So, ilan to? J, 20 ohm. Right? So, ngayon, transform natin uli in terms of phasor form, yung mga circuit elements. So, itong 10 millifarad, ano na siya? Negative J, 25 ohms. Itong 5 Henry, J, 20 ohms. And then, itong voltage source, 20 angle negative 15 degree. So, hanapin daw natin itong V of T. So, pwede natin gawin is i-combine natin itong impedance na to, parallel lang sila, right? Tapos, pag nakuha natin yung equivalent impedance na to, pwede tayong gumamit ng voltage divider. So, ibig sabihin, masasolve natin yung voltage dito sa impedance na to, dahil parallel sila, yung nasolve nating voltage across this branch using voltage divider is dapat equal lang din dito sa dalawang passive element na capacitor at inductor. Principle of parallel circuits. So, therefore, kung ano yung masolve natin by voltage divider, ito na agad yung masasolve din natin voltage dito sa inductor. Okay? So sige, gawin natin. Combine natin itong impedance na to. So let's say, Z1 na lang itong impedance na to, yung 60 ohm. Tapos Z2, yung parallel combination nitong dalawa. So katulad dun sa taas, dahil parallel sila, tapos dalawang circuit elements, dalawang impedance, formula is product over sum. So we have negative J25 times J20 over their sum. So negative J25 plus J20. So ilan to using calculator? J 100 ohm. Okay? So therefore using voltage divider, yung V sub O na equal siya sa itong parallel combination na equal sa Z2 over yung sum nung Z1 tsaka Z2. So Z1 plus Z2 then times yung voltage source na Vs. So, plug in natin yung value. So, Z2 is J100 over Z1 is 60 plus Z2 is J100 times Vs na 20 angle negative 15 degree. So, using calculator, anong masasolve natin? Represent natin in terms of polar form. 17.15 angle 15.96 degree volts. Now, transform natin siya in terms of sinusoid form. So, V sub O of t is equal to yung magnitude na 17.15, then cosine 40, right? Then, yung phase angle niya na 15.96 degrees. So, positive 15.96 degree volts. So, therefore, this is the final answer. Okay? Next, we have, find the current I in the circuit below. So, hanapin daw natin yung current I dito sa circuit. So, mapapansin nyo, itong current I, parang siya yung magiging total current sa circuit, right? So, pwede natin i-apply yung Ohm's law na I is equal to V over total impedance para masolve natin si I. So, kailangan muna natin hanapin yung total impedance nitong part na to. Okay? Kaso kung mapapansin nyo, hindi siya simple series to parallel circuit. Meron tayong nabuong delta tsaka Y connections dito, right? So, therefore, apply natin yung formula doon sa delta at Y network. So, pwede kong gawin is itong delta na to, pwede nating i-transform into Y. So, bale, so parang ito yung isang impedance, tapos ito yung isang impedance, tapos ito yung isang impedance. So, ito, 2 minus J4. Okay? So, ano ulit yung formula natin for delta to Y? Kasi delta to, diba? Tatransform natin into Y. So, parang magiging ganyan dapat tayo. So, ito yung mga magiging equivalent impedance para doon sa transformed Y. So, ang formula natin is, so let's say dito muna tayo sa Z1, tapos Z2, Z3. So, for Z1, ang formula natin for delta to Y is, kanina, yung denominator nila is dapat pare-pareho. Yung sum ng impedances ng mga delta. So, J4, 8 ohm, tsaka itong 2 minus J4. So, we have J4 plus 8 plus 2 minus J4. Tapos, yung numerator for Z1 is yung dalawang included na impedance sa kanya, which is itong 2 minus J4 tsaka J4, right? So, multiply natin. So, J4 times 2 minus J4. So, ilan to? Using calculator. 1.6 plus J times 0.8 ohms. Okay? Then, itong Z2. So, Z2 is equal to, so, same denominator lang din tayo na to, ha? So, copy ko na lang. And then, yung mababago is yung numerator. So, this time, ano yung dalawang impedance na na-include si Z2? Itong 2 minus J4 tsaka 8 ohm. So, multiply natin sila. 8 times 2 minus J4. So, using calculator, ilan uli ito? 1.6 minus J times 3.2 ohm. Then, last, itong Z3. So, Z3 is same denominator. Then, yung numerator niya is yung product ng dalawang impedance na naka-include sa kanya. Itong J4 tsaka 8 ohm. So, multiply natin J4 times 8. So, using calculator, ilan siya? J times 3.2 ohms. So, pag transform natin ngayon, yung bagong circuit, so, i-delete na natin to, right? Tapos ito. Tapos ito. So, anong kinalabasan natin? So, ito si Z1, ito si Z2, ito si Z3. So, pwede natin gawin is i-combine natin to as one impedance, combine to as one impedance, and then combine to as one impedance. Kasi pare-paro na lang silang series, right? So, let's say 12 ohm plus yung Z1, let's denote as Z4. So, 12 ohm plus Z1 natin kanina is 1.6 plus J times 0.8 ohms. Ilan lahat to? So, parang 13.6 plus J times 0.8 ohms, right? And then, ito, yung negative J3 ohm plus itong Z3. So, let's say Z5 yon. Negative J3 ohm plus Z3 na J 3.2 ohm. So, mamamay-minus sila. So, magiging positive 0.2 J ohm na lang. Okay? And then last, let's say Z6 naman tong branch na to. So, Z2 plus yung sum nitong J6 ohm tsaka 8 ohm. So, Z6. So, J2, ano yung J2 natin? 1.6 minus J times 3.2 ohm. And then plus itong J6 saka 8 ohm. Plus J6 plus 8 ohm. So, ilan total nito? So, we have 9.6 plus 2.8 J ohm. Okay? So, therefore, ano yung total impedance niyan? So, parallel itong Z5 saka Z6. Combine natin. And then, add natin dito sa Z4. So, therefore, Z total is equal to, so, Z4 plus parallel combination nung Z5 tsaka Z6. So, ano yung Z4? 13.6 plus J times 0.8. Then, plus formula for parallel circuit, yung dalawang impedance. So, multiply natin si Z5 tsaka Z6. So, J times 0.2 times 9.6 plus J times 2.8 sa numerator, product. Then, add natin sa denominator. J times 0.2 plus 9.6 plus J times 2.8 ohm. So, using calculator, ilan to? Gawin na lang natin in polar form. So, ZT is equal to 13.64 angle 4.2 degree ohms. So, using Ohm's law na, we have I is equal to V over ZT. So, yung V natin is 50 angle 0. So, 50 angle 0 divided by yung ZT na nakuha natin, 13.64 angle 4.2 degree. So, ilan to in polar form? Approximately 3.666 angle negative 4.2 degree. Right? So, the unit is ampere kasi current. Okay? So, I think that's it for this video, impedance combination. So, practice lang kayong mag-solve ng combination of impedances problems para ma-master nyo yung ganitong topic. Okay? So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.